Okay, well, that being said, I'd like to welcome all of you to this latest Holophon workshop using NanoSense Arduino Part 2. And we'd like to thank multiplay.ca for funding these workshops. Because Holophon is a Regina-based organization, we would like to acknowledge that the land on which we gather is Treaty 4 territory, traditional territory of the Saulteaux, Cree, Dakota, Lakota, and Nakota peoples, as well as the homeland of the Métis. So I'd like to introduce Ian Campbell. Ian Campbell is a filmmaker and multimedia artist who works in video, installation, and performance art. His short films have been screened across Canada at film and experimental video festivals such as Festival du Nouveau Cinema in Montreal, Windex in Winnipeg, Antimatter in Victoria, 8Fest in Toronto, and others in Europe and the US. He has presented performance work using live improvised projected video at artist-run centers and performance venues across Western Canada. He is currently based in Saskatchewan, where he teaches film at the University of Regina. Thank you, everyone, and I'm going to turn it over to Ian.
Thank you. Can everybody hear me? Okay. I'm going to start with this PowerPoint here. Just going to make myself really tiny. There we go. This is part 2 of the workshop. So the first part was kind of an introduction to Arduinos in general. I don't know how many of you have an Arduino that you're going to be using tonight, but if you do, you can sort of follow along. Now I have made this PDF available on the Holophon Gmail account. So if you do want to take a look at any of the materials here, what I'll do is I'll just copy this link and put it into chat. So you can either tonight you can either use the Arduino Nano, which is the newer one that's got all the sensors on it, or I also made a patch that you can use one of the older Arduinos. Like this is an Arduino Uno. You can use. I made a kind of something called what did I call it? Fake sensor, so that you can kind of go through the motions of it without actually having the sensor data. So here's what we'll do tonight. We'll do an overview of the Arduino IDE, which means Integrated Development Environment. We'll take a look at Blink, which is usually the first sort of patch or program that you load up when you're starting with Arduinos. We'll look at a little bit of basic syntax for programming in Arduino, the language, which is a sort of a version of C++, but we'll take a look at some libraries and how to add a library, which is also really important. We'll take a look at the Nano sensor examples that comes with the library, and we'll figure out how to modify them for what we need to do. Then we'll do a break. And then I'm going to sort of introduce the second piece of software, which is called Pure Data. And we're going to use that to get the information from the Arduino sensors into basically a very, very simple sound synthesizer. And then I'll talk about sort of future MIDI kind of stuff. If anybody has any questions as we go along, you can definitely ask them anytime. I think we have lots of time tonight for what I've got, so no problem in fielding questions. If you want to put them in the chat too, I've got the chat open here, so I should be able to see them. And if I don't see your chat, somebody can just like speak up and I'll take a look at the chat. So here are the two pieces of software that we're going to be using tonight. You can download those. Both of them are free, so you can get them no charge. They're both open source software. And they come for Mac, Windows, and I think Linux. I think they both have Linux installs too. This is the link with the files we'll be using tonight, and then this PowerPoint as well. One thing I want to mention just before we start is just handling. So generally these devices are pretty rugged, and it's hard to really wreck them. But you can short stuff out, which that just means that if you connect the wrong two little pins on here, you can connect the positive and the negative together, and that can be bad news for your chip. So what I've done with mine is I've just put some tape on here. If you can see that in the corner there, just put a little bit of sticky tape on here, just so that the pins can't touch anything metal, and then short out. I've noticed on the website that they sell these little rubber cases that you can put these into. Normally, you would have this plugged into a breadboard or a proto board, and the pins wouldn't be exposed like that. But I guess because these are sold maybe to people who aren't necessarily having all those accessories, I just like to have a little bit of tape on there so that they don't get ruined. I did short it out earlier this week by just touching it just for a second. I touched it in the wrong place on my lamp, which just has these kind of wired, this like piece of wire around it. So it made a circuit, and then it stopped working. So make sure that you're, if you're following along, make sure that you're using the most up-to-date version of the Arduino IDE. So you can download this, and it will just install over the old one if you have an older one. Yes, Bernie. I'm just going to throw up this link again. What we'll do is we'll get into the IDE. So I'm going to start with just opening it up. So after you've installed it, you could just double click on the icon. And this is a window that will pop up. This particular window is basically just it's sort of like a blank window. It's got the date on it, and it says sketch. It's got the two important things, but basically two the structural content of every program is to have a setup and a loop. We can talk more about that in a minute. But this is like an empty program. So the two things that you need to do before you can get started is you need to set up your board, and you need to set up your port. Setting up your board means you need to know which board that you're using. So this is your the Nano 33BLE. That's the one that I've got here. And you just need to go through here. This is the Arduino Mbed is the sort of newer versions of Arduinos that are being that they're coming out with. It's a newer chip that they're using, so this is kind of like the newer ones. All the older ones use the AVR, and AVR is just another brand of chip. So my older Uno here would be one of the AVR ones. The next thing is setting up your port, and for the Mac, the port is it has a sort of a name to it and then a number at the end. And you can always tell which one is the Arduino because it says Arduino on the side. You'll probably recognize some of these other things here, like there's a Bluetooth port. There's always this URTO port, and sometimes you get some other stuff here. But the Arduino one should be fairly recognizable. It always says USB modem and then a number. This is what it looks like on Windows. So if you're on Windows, it's fairly similar, except for the ports, you've got COM, a couple of different COM numbers. Depends how many, how many USB ports you have on your computer and what's plugged into them and all that stuff. So let's see and make sure that we've got this hooked up here. So I've got my Arduino Nano 33B LE. That's the chip that I'm using, this one here. And I've got my USB modem 14101, which is also the Arduino Nano 33B LE. So in order to test it, we should probably use a blink script. This is just a description of the basic kind of parts of the screen. Up in the corner, we've got two buttons that are really important. One is called verify and the other is called upload. And verify is basically, it allows you to check your program, make sure that it's running properly, and it will, if everything's okay, it won't give you any error messages. So it's basically compiling it. The second button, the upload button, the little arrow, that will actually send your program from the IDE to the Arduino itself. And it will actually verify it and then upload it after that. Over in this corner is the monitor. The monitor is like it's like a way to communicate with your Arduino. It's kind of like a little it's what's called a serial monitor. So it's receiving information and sending information over the USB cable from the Arduino to your computer. There's also a really neat function in there that's a plotter that allows you to graph out information. Down here, you want to keep your eye on this down here. Because that tells you exactly which board you're working on and the port. There's a question in the chat here. In the boards manager option, I had to install Arduino Mbed OS Nano boards to see the Nano 33B LE board in the tools menu of the IDE. That's very possible. Yes.
Yeah, sorry, not a question, more of an FYI in case anyone else was scratching their head while they didn't see the same things you did.
Okay. Yeah, that makes sense. Are you on Mac or PC?
PC.
Okay. The Mac version and the PC version are very, very similar. There are some slight differences. And if you don't see the any of the nanos coming up, we're going to load the libraries in a second, and that will help things. Over in this dark area here is your error log, so you can look at. It'll tell you if you make a mistake in your programming. It will give you. Sometimes it gives you information about why it can't compile. So it can lead you towards issues and stuff that you can fix. And then generally it tells you how big your program is and all that kind of thing. And it'll also give you a little readout when it's uploading. This is the code. So the colored, I would say black, the blue, and the orange writing is all the various code. And then up here is the gray. This gray part is just comments. So you'll see lots of commented parts in all of the examples that you can look at. So here's the first thing you need to do if you are using the Nano 33, or if you want to use any library, basically. Remember the library, like I talked about last time, libraries are things that people make to use certain pieces of hardware usually, or to do a certain function in the Arduino. And the library we need is going to be this Nano 33BLE sensor. And it just makes use of everything, so it makes it much easier for us to access the sort of functionality of the chip. So I'm going to go up to Tools and then Manage Libraries. And then this little window pops up, and right now it's just showing us every library in here. So what we need to do is we need to narrow it down to what just the stuff that we want to see. So I type in Nano 33, and then it's got a whole bunch of stuff in here, but each one is related to that. So what we're looking for is we're looking for this Nano 33 sensor. I've already installed it, so it says install here. But if you haven't installed it, you can click the install button that would be down here. And if you install this library, it will install all of the sensor libraries up here. So this is the color one. We're going to use the color sensor. This is for pressure. This is the accelerometer and the gyroscope. We might be able to look at that later. So basically everything that we need in terms of the sensors that are built into this chip. Like I said, in terms of the structure, there's two main blocks where we can put our code. So the first block is your setup. And the setup is, like it says here, put your setup code here to run once. And generally that's for when you need to set up variables, or you need to load a library, or you need to do something that only does it once right at the beginning. You put it there. And then the loop is basically runs continuously as your Arduino is on. So that's where you put your main code. And pretty much all code is designed to work in a loop, and it just runs continuously, and it continuously gets some sort of there's some sort of algorithm that it goes through. Sometimes it's very quick, where it just does a simple thing over and over again, and sometimes it's slower and there's a lot of steps to it. But generally, that's the code. Each function is in orange. So these are the built-in languages that built into the language or come from the library. So in this case, it's pin mode would be one function. You can see up here it says initialize digital pin LED built in as an output. So the pin mode is basically just it's telling the Arduino that we want to use this pin for this purpose, and we're making it an output, which means we're going to send information to it rather than receive information from it. And the information for a single pin would be, is it on or is it off? It's pretty simple. It's that's the sort of binary logic of the microcontroller, or the tiny computer chip. The functions have variables and constants in blue. These feed data to the functions. So LED underscore built-in would be a variable. And a variable is just like a little box that you would hold a number. Every line must end in a colon, except for statements and loops. So you can see at the end of this pin mode, there's a colon. If you left that colon out, it would be a syntax error, and the program wouldn't continue, or it would stop. Let's go up to File and go to Examples, Basic, and then Blink. So this is a list of examples that we can load, and it's one of the best ways to learn how to use the Arduino is to use examples that you find in this list. So if I load the Blink example code, if I was to click the verify button, it would compile the sketch. And then when it's done, it would tell us how many bytes it takes up. One of the things I've noticed about this particular board is that the compiling takes a long time. The Nano, I think, is because it's a larger, it's got a whole bunch more information that you can put in here in terms of like RAM and ROM. It's just going to take a lot more time to upload. So it says down here, Sketch uses 85,248 bytes, 8% of program storage space. Maximum is 983 40 bytes. So basically, we're only using 8% of the storage space in that particular in the chip. Global variables use 44,184 bytes, 16% of dynamic memory. So that would be just the memory part. So memory, of course, is used for like shorter term things, like I need to store a number that's coming into the Arduino for just like a couple of seconds, and then I'm going to change it for another number. And then 217,960 bytes for local variables. So variables would be like this LED built-in would be a variable. And then there's a maximum there too. So we're like way under what we, this is like one of the simplest programs, so it doesn't take up much room at all. If I was just to make like this, say I was to delete this semicolon here, and then I did that, it would give us an error message. So it says here, it gives us a, where this file is. So this is the Blink. It's on where it is on our hard drive. And then it tells us which function the error is, and then it says error expected semicolon before curly bracket token. So it's basically telling us that this pink line here is telling us you should have put a semicolon there, because the semicolon basically just tells the computer or the compiler, which is making the code for the microcontroller. It's just telling us that that line is done. It's over. So that's why the computer kind of always has to know where things begin and where they end. And that's called delimiting. And the semicolon is our delimiter. If I put it back and then I did it again, it shouldn't complain. Oh, that went a lot quicker that time. Let's look at the bottom here. So it says this loop function runs over and over again forever. So basically what this is it's just turning the light on and off, the LED. And it's saying digital write, LED built in, high. So it's basically just changing that pin, which has an LED connected to it, to 5 volts. So high in the Arduino means 5 volts, low means 0 volts. So you're just dealing with like turning voltages on or off. That's kind of like the digital part of the Arduino. We can also use analog. We can make analog voltages out of them too. But for the digital part of the Arduino, it only has those 2 states, high and low. And then we have this little function here, delay. So delay is very simple and easy to understand. It basically just stops and waits for a certain amount of time. And the amount of time that we're waiting is 1,000 milliseconds. So 1 second. And then you can see it goes to, turns the LED off, and then it delays again. So it's basically just a blink on off. So if I was to click the upload, and if you were to look at this Arduino in the corner here, you should see the yellow LED go on. It just kind of turns on for a second. And now you see how it's blinking? That's your basic code for starting things out. It's basically like if you've ever heard of Hello World. Hello World is like the first program you make when you're programming in most languages. Okay, I'm going to change this 1,000 to something else. So let's say 200. And we'll send it again. So when it's compiling, basically it's turning the human readable code into machine language. See how the yellow LED is blinking kind of faster now? And let's change them both to 50. Now it should blink really fast. So super fast by changing the it's not a variable, but it's a just a number. A number, I would say, I guess, a property. Okay, so that's your basic getting started. Is anybody having any trouble if you're following along at home? let's take a look at the examples for specific to the Nano. So the example that I want to look at, well, all of the sensors are here. So each one has a a big long model number associated. So APDS9960. That's the light sensor basically, and it's a light sensor that can handle color. So it can tell you what color is. It's like a 1-pixel camera kind of. This is the temperature and humidity. Or no, that's the temperature, that's the humidity, and then there's the gyroscope and accelerometer. So I'm interested in this color sensor, so let's load up that one. The examples are kind of like every time you, well, first of all, the Arduino comes with a whole bunch of examples. So all of these things here are different examples. And if you want to sort of learn the coding, just go through every one of the examples, and you're going to learn a ton of stuff. It's kind of like the best way of doing it. And then every time you load a library, you get more examples. So let's take a look at this color one. So I'm going to close that one. Don't save. So here's the color sensor code. So slightly more complicated than the blink, but not really too much. It's got some comments at the top, so the computer doesn't run anything when you see those comments. So comments are either /* and then ends with the */, and this whole thing is a comment, or it's just 2 slashes, and that's a comment. So basically, the computer, if it sees those, it just ignores them. So at the top here, it says include Arduino and then the APD S9960. So it's basically including the library. Libraries are generally, they're a text file that usually ends in .h. And so this has sort of been provided by maybe the manufacturer, maybe some kind people in the community that have written it. But libraries are so important. That a lot of times it's the only way you can actually use the equipment or the hardware that you want to. Then we have our setup, and we've got this line here. It says begin serial, or sorry, serial.begin 9600. So that's basically the code for starting the serial device, which is a way to print information out of the Arduino through the USB cable in this case. We've got while not serial, so the exclamation point is like a logic operator. It just means not. It just means if this is not something, then if this is not true, then do this. So basically, this is what's called an error handler, and all it does is it says if it doesn't hear from this begin, if begin is not present or not true, then it'll give us a error message, and the error message comes from this serial.println. So that's a function that just prints something to the monitor. And if we're using the Arduino IDE, the monitor is this thing up here. So if you open that, you'll get this window that will you'll see text printed there from each of these print statements. Now, ideally, we don't want that to have anything to stop there, because that would indicate an error. So hopefully the program will just go past this and not stop. And then that curly bracket there is the end of that part of the code. And then the next one is the void loop. So again, this is the one that loops forever. Check if a color reading is available. So that's just the comment there. And so there's another kind of an error message or a way of like slowing things down here. It's saying is color available? Delay for 5. So 5 milliseconds. It's a very tiny little delay, but obviously it's needed for this particular code. Basically, I don't want to touch any of this stuff because it's already been designed and it works. So I don't want to touch it. Then we get down to this int RGB. So int RGB means integer. I want to create 3 integers, R, G, and B. And the integer or int just means it's a number of a certain size. So an integer is, I think it's like 32,000 to minus 32,000. So it's like a certain amount of space in the Arduino's memory. But these are our first sort of variables or user-defined variables. And a variable you can call anything, right? It can be a name, it can be a word, it can be a letter, it can be whatever you need. And the reason that we want those 3 variables is so we can put the colors inside them. So this function here, apds.readColor, all that does is it takes the information from the sensor of red, green, and blue, and it puts it into the variables RGB. And then it says print the values, and then you have a whole bunch of print statements. The print statements are basically, there's 2 different ones. There's print and print ln. Print is just prints, print ln prints, and then drops down a line to the next line. So you'll see them printed on different lines if you've got the print ln. So the R equals this right here would be what we call a string. A string is like just words that would be, they're like kind of human readable words. So a person's name or a message or something like that. We put it in the string. So strings need to be delimited or marked out to the computer with quotation marks. So it's got to have quotation marks around it for it to be a string. And then right down at the bottom, you probably know what that is. It's just a 1 second delay. So let's upload this to the Arduino, and I'm just going to watch and see if the little yellow LED stops blinking. There's a kind of a blue line at the bottom, right down here, which is very similar to the blue of the background, so it's hard to see, but the blue line is going across and it's just compiling this sketch. And then you get that little orange. Okay. So nothing's happened. The little green light is on. That just means the power's on. The yellow light's turned off. But something up here is happening. in that there's code coming through the monitor, the serial monitor. And now we're getting information from the light sensor. So if I put it under the lamp here, it goes up really high. So we're at 4,000, 3,400, 3,500. I move it away into this sort of if I go down here, I'm just going to make this bigger. If I turn this upside down, you can see that it's not much light is reflecting off this black mouse pad. And so we're getting lower. Generally, within RGB, if you know anything about RGB values, you know, RGB, red, green, and blue make up all the colors in a pixel. If RG and B are all 0, that means that the color is black. If they're all higher number, that means the color is white. And if they're different amounts of them, then they're different amounts of red, green, and blue. So for instance, if I took this piece of red cellophane and I just put it over top of, we should see that the R number is a little bit higher than the others. You can see the G number goes down quite a bit. The B is sort of a little bit down. So R is at 300. G is at 170, 180. B is at 200. If I like, so basically, we're getting, it's giving us color values, just in terms of numbers. Now remember that this sensor requires light. You can't, it's not going to work in darkness. It only works in terms of light reflecting off of an object, say. Okay, so this is sort of half of what we need in terms of our sort of goal. I think I typed the goal out here. Hold on. Oh, I should mention this too. So this is our Arduino reference website. So when you start learning about the Arduino and the language, this is a great site to use to kind of learn about all of the different functions in the Arduino. So the language reference has sort of different categories. So you've got digital input output, you've got analog input output, you've got math functions, randomization, bits and bytes, characters, so that would be all about strings or working with strings, time, USB, different types of variables. Here's an int. Let's just see what int, how they define it here. Converts the value to the int data type. So the different data types are, you store different types of information in different data types. So for instance, Here's the description of the int. So this is, if you need to store a number that's say you have a number that's going to go from, I don't know, 1,000 to 30,000, you'd have to use an int, because other types of data types would run out of memory. You wouldn't be able to store that high of a number, 30,000, but you can store up to 32,776 in an int. And this is just basically how computers work. You need to define the data type that you're going to use. If you wanted to save a little memory, you could use a byte maybe. So a byte stores an 8-bit unsigned number from 0 to 255. So if you know that or your number that you're going to use in your program is never going to go above 255, then you could use a byte, and you'd save a little bit of the memory. That's probably only useful if you've got a very, very like a microcontroller with a very, very small memory. Control structures are one of the most important things. These are different types of loops. So you've got the loop function, but inside the loop you'll have other loops. You've got for loops, which are a defined loop that goes from one thing to another, say, like from 1 to 10, and it just counts up. You've got while loops, which are only loop while a condition is, say, true. And then comparison operators, those are also very important in terms of, is this greater than or less than? Is this equal to? That kind of thing. And if statements. So if statements are like probably one of the most important control structures. We saw how it was used to create an error handler message. It's basically, this is that if the condition is true, then the statement is executed, basically. So you can use it to have your program make decisions. So that the reference is a great resource. And this is just all of the built-in information or the built-in functions in the language. This doesn't include all of the libraries. All the libraries would be extra. And each of the libraries would have their own kind of reference. Okay, so here's the goal that we want to do. For this workshop, we want to combine two pieces of code that do separate operations into one piece of code that does what we want. And what we want to do is we want to send the red, green, and blue values from the color sensor of the Nano 33 to the sound synthesizer. So I'm going to take this code and I'm going to I'm just going to tweak it a tiny bit to allow us to send it to the pure data program. So I've got this other program here. Oh, I have to open it from a different place. So in the Arduino, the Arduino makes a folder when you install the Arduino software, the IDE. It makes a folder in your documents, and it's just called Arduino. And then inside that folder are all your libraries, and then there's also, it will add a separate folder for every program that you make. So I just want to open this one. And it's going to create a folder and then move the file. And I'll go, okay. Oh, it says it already exists, but I don't see it. Maybe I can open it here. Okay, there we go. So you don't have to do this. I'm just doing this as an example. What we're going to do is we're going to use the code that I've made and that's on the Google Drive. But I'll just use this as an example of sort of like patching together things. This is like 99% of the stuff that I do with the Arduino is I use it. I take a little bit of this code and I put it with this code, and as long as the syntax is right and it's doing the right thing, then you're okay. So this is called serial print, and it's just a basically just a bit of code that will format some information in the correct way so that we can send it to pure data, which is another piece of software. So it's kind of like formatting information. And because this is not formatted, the color sensor is not formatted properly. Well, we need to figure out how to do that. So this has got a bunch of stuff here. It's got some constant int. So those are like constant is like something that is a variable that would be available to the entire entire Arduino. And then you've just got regular ints, which would just be available to certain parts of the code. You've got a for loop there. So the for loop is basically it's saying it's going to start at 0. It's going to go. It's going to add a single digit, and it's going to go up until keep counting up from 0 until it gets to the number of digital pins, which in this case is 3. And it's going to change these. This is input pull up. That's just like sort of a technical thing for the board to turn on a little resistor that's inside the board. This one is going to check all of the analog pins up to 3. This one is going to check all of the digital pins up to also 3. And then it's going to start printing them. And the key here is that we need this code here, serial print, and then a string that says analog underscore values : and I'm just going to highlight this, and I'm just going to go Command C to copy, and then I'm going to put it over here. So I'm going to put it into my before all of the RGB stuff. Then what I need to do is I need to make sure that all of this is printed on the same line with spaces between, because it needs, for the formatting of the data, it needs to have spaces. So I'm going to go delete this one. And I'm going to put a space, put another space. I'm going to turn these so we can't go to a new line until all of the numbers have been printed out. So I'm going to remove the LN on these. And then the last line, it can be it'll print a line. And then I think the last thing I'm going to do is because I want this to happen a little bit quicker. I want this to be a smaller number. So I'm going to change this to, I think, 200. So it's just going to wait 200 milliseconds between readings, basically. Basically, this is kind of like sampling. It's sampling information. It's sampling a sensor. It's like going to a sensor and saying, what value do you have, Mr. Sensor? And it's putting that value into the serial print or the serial monitor. And then the other program is going to read it. So let's try uploading this and see if it works. Well, there's no errors. And then I'm going to look in the serial monitor. So it's just printing out all three of these values. And you can see that as I move this around, put my hand over it, it goes small. Take my hand off, it goes big. I don't know if I can, probably should have done this before. That sort of works. Okay, so this is the plotter. So the plotter is nice because it, instead of reading the numbers, we can see them much more visually. So that's dark. That's light. Point it towards the lamp here. So depending on the data that you're trying to visualize, the plotter can be really, really useful in terms of looking at the data. Okay, so last thing I need to do, I don't need this one anymore because I've got what I needed from it. I just need to save this. So I'm going to save as, and I'm going to put my name on it. I like to put my name on the code that I make because sometimes you get mixed up with different pieces of code all over the place, and you don't always know who made what. So I just stick my name on it, and then I save it. And then you should see that it's made a new folder here called Ian Color Sensor, and then inside Ian Color Sensor is an .ino file. So I need to, once I've got that loaded, and if you want to do the same thing, if you want to load the code onto your Arduino, you can download this one called Ian_color sensor INL. You can use that. If you don't have the Nano with the sensors on it, if you have maybe one of these older Arduinos, you can load the fake sensor on there. Fake sensor is just all it's going to do is it's going to put 3 random number generators on your Arduino, which will just spit out numbers. They won't have anything to do with sensor, they're not connected to anything, just randomization. But you can use it if you have an older Arduino that doesn't have the sensors, and then you can do the second part of the workshop. Does anybody have any questions? Anybody, you want me to go over anything just before the break? Okay. The next part is going to use the pure data language. So I'm going to close my Arduino IDE, and we're going to use PD. So if you've downloaded PD, you can install it during the break. Right now it's 8:03. So let's just take 5 minutes and come back at 8:08, and then I'll go to the next part. So I'm just going to install my PD here. So pure data, got a slide here. Programming language, a little bit different than the Arduino. It's usually used for real-time music and sound applications, as well as video. Open source, like the Arduino, so free. Developed by lots of generous people on the internet to make this stuff for everybody to share. It's a visual object-oriented interface for the programming. So that means that instead of typing in lots of keywords and functions and variables and that kind of stuff, you make little blocks, and then you join them together with little lines, and you can create lots of different programs using that method. I'm just going to install it on OS 10 because I'll just use this as an example, just because there's a little bit of it's a little tricky. Because I think because it's an independent project, Apple doesn't seem to like it, or hasn't given PD any sort of authenticating whatever is required by Apple for authentication. So you have to kind of go around the security of your computer a little bit if you're on the Mac. If you're on Windows, it installs really easily. So I'm just going to double click this. This is the archive, and then inside the archive is the application. So if I double click the application, it will say it cannot be verified because the developer cannot be verified. It can't be opened. So I'm going to go cancel. So here's how you get around security if you have open source software that you can't install. You right click and then click open. And then it gives you the same information, except you have the extra option of being able to open it. So let's open. So when you open PD for the first time, it wants you to add a folder just called PD in your documents. So I'm going to do that. And then choose documents. And then oops. Oh, that's interesting. Let's try it again. That time it ran. Okay. So I'm using PD because it's really easy to get the information from the Arduino to PD. Plus, PD gives you a lot of opportunity to use sound synthesis, to experiment with sound synthesis programming. So I've made a short, easy to understand kind of program for us to use. So remember, we're taking the RGB values from the chip, and we're going to turn that into music. So this is the main window in PD. This is kind of like, this is where you'll see the error messages. It's just got a couple of buttons and stuff up here. So what we need to do is we need to open a program. So this program here, which is on the Google Drive, is called ian_synth.pd. So let's open that up. This is what the programs look like in PD. So you've got a whole bunch of different buttons. These are buttons here, on and off. These are buttons. If you see a little an object that has little kind of pointy corners here, that's called a message, and it means that you can click on it. So the first thing you would do if you're opening this on your computer is you want to see if you're on the right port for your Arduino. If I click devices, usually takes a second. And then it comes out with COM port, available serial ports. If you don't see that, or if you see COM port, this COM port object here has a dotted line around it, that means that you don't have the COM port library yet. And just like in the Arduino, has a whole bunch of libraries that increase the functionality of the program. So does PD. PD has a whole bunch of libraries. So what we might need to do is load the COM port library into your version of PD. So what you do is you go up to the help in the menu, you go find externals. This window pops up, and we're going to type in COM port and then search. So COM port, it's just all it does is it connects an Arduino over the serial to your PD. In PD, okay, so in Arduino, programs are called sketches. In PD, programs are called patches, and it comes from Patch Bay of like audio hardware, that kind of thing, modular synths. So you just say, yeah, do you want to install this? And I'll go, yes. You always want to get the latest version. So the latest version here is 1.1.1. It's from 2017, but that's the latest version. When you see up here, it says Darwin, that means that'll work on Mac. And then x86, 64, 32. So that's the chips that it'll work on. So that should work on Intel as well. Okay, so it doesn't really tell you if it's installed or not, but if you're having troubles, I would just quit PD and then start it again, and I can actually, I don't have to click this one. I can just click the patch here. It should open PD in the program. So, so here's how to edit in PD. So PD has two kind of modes. One is the mode is you're clicking on various buttons. You're moving sliders. That's a slider there. It moves around. You can see this numbers changes. I can move up and down with the numbers. Move across the slider. I can turn this on and off. So that's like the control mode. The other mode is edit mode. And right here under edit, on the Mac, it's Command E. It allows you to start editing the patch that you've got. So if I click that, it will say edit up here. And then if I try to click something, I can't do it. I'm moving things around. And this is how you program in PD. So you can see I can move stuff, draw a box around it, move it around, move things around. I can go in here and I can change this number. I can do all kinds of stuff. But what you have to do before you can get your Arduino to talk to PD is you can, you need to look at, after I've clicked the devices button, COM port basically gave you this information, which is all the devices that are connected to your computer. And if you remember from Arduino, and you're on a Mac, this is what it looks like. This is your Arduino there. So that is port 3. So you have to say COM port 3. So what I would do, if that didn't say 3, I would erase that and type a 3 there. You can see there it says open serial line device 3. Then if I want to go back to operating the this program, I would go back to turn edit mode off. And so you can see that we're actually, it's actually working. Do you see these numbers changing here? So I move this around. This is, it's getting information. It's getting color information. So the first number is R, or red. The second number is G, green. The last number is blue. You can see how much red there is. Now, what does it do other than the numbers changing? Well, I'm just going to share my audio here. You're going to have to tell me if you can hear anything.
Turn your DSP on, Ian.
Hear that?
Sure do.
All right. So there's your volume control. Don't want to make it too loud. And I'll just explain this here. See, as I move this closer to the light, farther away, see what the red does. Not much. Okay, so we're getting our values are coming through here. So it's coming through the COM port. It's doing stuff we don't really care about what's happening in here, but it's going all the way through here and it's getting to these three numbers, RGB. And then this line here, so we're only using this single number here right now. This line is going into a multiplication. So asterisk just means multiply in computer programming. And it's multiplying by a certain amount. Now the default number, or the number that's preset, or that it starts with, is 10. But you can also use this slider to change that number. It doesn't change, you don't see it change, but it's changing. It's basically kind of like an octave slider. Now it could get up too high, we can't hear it. So as that multiplier is multiplying, this number will change. So it's taking that number times whatever this is. I can show you what it is actually if you want. I'm just going to go. Let's move these down. So multiplied by 5.24, multiplied by 10.64. Then it goes down. This is just another number box. So these boxes are just, you know, I just put that one in so that I can see what the multiplication is. It doesn't do anything. It just gives us a feedback of that. Lets us know what number is flowing through the system at any given time. Then it goes to an OSC tilde. So that is an oscillator. So it's just like a it's creating a sine wave. Then it goes out of the oscillator into this, and this is sort of a similar multiplication, except it has a tilde beside it. And whenever you see tilde, so the tilde's all over here, it just means that sound is going through this part of the program. And then it ends up at a DAC, a digital audio converter. So it's basically just a, it's sending it to the left and right channels of the computer so you can hear it. Over here, your volume is basically, I think this is dB to RMS. So it's basically getting a value in decibels, and then it's converting it to what it would need to be to have an equivalent volume on here. So that's the basics of that piece of software. So let's experiment with something and see how. You got a PD problem, not working on your Mac. It opens then closes, no error message. What version OS are you running? So I'm on Catalina. Oh, 10.13, yeah. I was going to say if you had whatever the next one to this is, that would be the issue. But could you try dragging your PD into your applications folder and see if that makes it happier? That's all I can really think of right now. You did that, okay. I'll have to think about that. The only thing I could recommend, tried reinstalling from the new download. Yeah, PD is usually pretty good on Macs. You could try one of the older versions. That might be. It hasn't changed too much, so you still do what we're doing today. But yeah, I don't know why it would crash like that. Well, anyways, if you can't get it working, just watch along, and maybe we can maybe Google it later. Okay, so let's just do a little experiment here. So I'm going to take my we got a little turntable here. I took the needle off so that I don't wreck it. And then I'm just going to tape this here. Oh, here's some tape. Always have gaffer tape on your, always have a little bit of gaffer tape on your table legs, just in case. I tried this yesterday and it works, but it probably won't work today. Now I wish this turntable had like a variable control on it, so that it would be a little more sort of slower. Got a nice boop going there. There's not much light over there, so. If there was more light on this side of the room here, our variables would be a lot different. Okay, so now let's just do a little hacking here and just move some stuff around. So I'm in edit mode, so I can move things. So what I'm going to do is I'm going to just take this whole section. Let's see. Take this part. I'm just going to move this down here. This section here. I'm going to draw a box around it, and then I'll just go Command D to duplicate. And then we'll run from the B. We'll run into here. So this number will go into this whole section, which is just basically another oscillator. And then I'm going to run the sound into there. And we'll put another color on. So we're getting just, it's not like it's recognizing anything in particular. We're just using the variations in color to kind of like make changes to the sounds. And then let's do this one too. So I duplicate it again, and we'll just run the other. Run that into there. Is that like a chord now? I don't know. Whoa. Ooh, something weird is happening when I crank up the volume.
I did that too, but I left that volume bit on each block and duplicated that, so you got like level controls for each one.
Oh yeah, okay, good. Now, if I put some more light here, everything would be completely messed up, I bet. Just moving this over. I'm just moving a desk lamp closer. And farther away. I find that when you're working with sensors, it's really important to have as much control as you can to the environment that they're in. So like if you built a sensor piece that's designed for to work in a certain gallery, say, or a certain studio, don't move it to another gallery studio. There's so many variables, especially when you're dealing with very simple sensors like a light sensor. Light sensors are just really dumb. So that's using pure data as the sort of sound source, I guess, or the I guess the synthesis part of things. I've added another little. Just turn the volume down. I've added another little extension here, and this is to use Pure Data as like a way to convert the data from Arduino to Pure Data, and then we could send it as MIDI to another program. So let's try that. We'll see if this works. I was messing around with this today, and it was working, but you never know if it's going to work or not. So. In Pure Data, there's a good little tester here. It's called Test Audio and MIDI. It's under Media. If you click that, you get this little thing, and you can use it to just test if your sound works. Clicking these, and you can also use it to test your MIDI out. So what we'll do is I'm going to run something into Ableton, which if you've taken any of our 2 Ableton workshops, you'd be hopefully somewhat familiar with Ableton. Ableton, I'm going to use it just as a way to send MIDI notes into an instrument. So I'm just going to use this synth lead. Okay, so right now there's nothing going into it. So in Ableton, MIDI information, you can set it up so that, like for instance, I can set it to computer keyboard. You should be able to hear that. Computer keyboard, it just means it turns your keyboard into a piano. I could use something like this and like send this information to this synth here. I think this one. But what we're going to do, or we're going to try to do, is we're going to try to send the information from Pure Data. So in order to do that, we need to make sure that we're using something called the IAC. In Pure Data, under Preferences and MIDI, there's a little window that says, what is your input devices? What is your output devices? So you can see I have the choice. I can use that keyboard that I just used a second ago and use this IAC driver. So I'm going to use the IAC driver. Should probably show how that's set up. Now, if you're on Windows, this is going to be completely different. You're going to use a different system. But the Mac has a built-in MIDI sort of distribution system or control system. And if you go into your audio MIDI setup, so maybe I'll go back to applications. If you go into your applications, you go into utilities, you go into audio MIDI setup. So that should be in your operating system, so you don't have to like download it or anything. This is setting up your various audio devices. And then if you go Show MIDI Studio, you should have this IAC driver in there. And you can click on the information. And if it's not, if it doesn't show up, if it's grayed out, you'd click this button here, Devices Online. Okay, so let's see if it actually works. So what it's the whole purpose of this thing is to send MIDI information from one program to another. Let's see if this one works. I've got to send it something. Oh, sorry, I forgot to do this. There's so many steps in this. If it works, I'd be surprised. Okay, so I'm going to set the IAC driver. I'm going to set this to in, and I'm going to just move this over here. I'm going to just take some numbers. So let's take this number here. So this number one, I can just take the output of this number, and I'm just going to put it into this here. So this is just a little black box object that just takes a number and sends it as MIDI information. Let's see if Live has the MIDI set up. Yeah, I got my input is here. My AC driver is there. Volume's up. Let's turn it to something else. I'm just gonna. Maybe the number's too low. Oh, that's too bad. It doesn't work. It doesn't work now. I wonder what changed. Make sure I have this MIDI set up. Yes. Driver. Set this up. Device is online. Oh. What is that? Oh, it's suddenly worked. I guess clicking that check mark made it work. Okay, so now the reason that you'd want to have the MIDI notes coming from, say, PD to another program is because there's so much more nuance that you can play with when you're working with a sort of more sophisticated synthesizer. So we can use all the wonderful kind of all the sort of wonderful effects of another kind of piece of software. Sorry, Bruce. Maybe it got stuck. Okay, now I think we're getting MIDI from something other than what I'm expecting here. So let me try sending to this port here. Come on. And of course, in Ableton, you can put all kinds of like extra stuff on it, like I don't know, some reverb or something fun. So we're sending note data right now. So it's just sending a series of notes. And the notes are coming from this make note and then note out. And you can see the information that you could change depending on your, what you want. You've got a rate, a pitch, a velocity, and a length. I'm changing the pitch. And I have this is changing it so that no value over 127 goes through to the pitch. So it's kind of sticking around under 60, 61, it looks like. Oh, it went to 92. This might be something that we might talk about later in terms of MIDI. But you can send all kinds of signals. You can send control signals and all kinds of other stuff from PD to another piece of software like this. So we could, for instance, change this parameter here. Any of these knobs you could change. There's a whole bunch of stuff. Run these at the same time. If we wanted to, we could take some of the code from some of the other examples and convert it to something that PD could understand. Maybe I'll do that. We'll see if I could do that. Is there any questions? Does anybody have any questions about either anything from tonight or just generally about Arduinos or electronics? You could just put it in the chat if you have a question. I'm going to save this as synth 2. Okay, in order to program the Arduino, I have to close PD because it's going to get confused. Okay, so I'm going to open up Arduino again. Instead of that one, I'm going to go into the examples and I'm going to go to, I think gyroscope would be the best one to try next. So let's take a look at gyroscope and see what we need to do to change this. Okay, so include the library, that makes sense. Serial begins, that makes sense. This is error Error handling, well, it's telling you when it starts. So when you turn on the chip, it would say started. Here's error handling. So if it fails to initialize. And then here is the sample rate. So I don't think we need any of this stuff. So we could just comment this stuff out. Because what's going to happen is if we leave that in, it's going to get confused. It's going to confuse pure data. There's a question in the chat. Can I use processing to write PD sketches? I don't really know much about processing, but they're pretty different. Maybe, I know with computers, anything is possible, right? It's just like, you just have to kind of figure out, how to kind of make things talk together. But I don't know.
If you look at a PD sketch, not in PD, it's actually like text that's arranged kind of in a certain way.
That's
so
true.
If you wanted to if you wanted to learn that, you could probably write a PD patch in some text editor. But compared to patching together things, that would be really, really arduous.
Yeah, you're totally right. You just need to be able to write text and then figure out all the sort of syntax. And so I'm just taking X, Y, and Z. I'm putting analog values at the beginning, putting a space between X, Y, and Z. I'm using print for all of these except for the last one. I'm going to do print line. And I think that'll do it. See, now this is a float, so it's slightly different. I think it's bigger than an integer. So these numbers might be a lot bigger than what we're getting from the color sensor. Okay, so now we have to save it as a new patch, or sorry, a new sketch. So I'm going to save as, and again, I'll just use my convention. I'm going to put my name at the front, and then simple gyroscope. Okay, so I've got my chip here. Oh no, that's the wrong one. It's on the turntable here. Floats will probably contain values after the decimal. Yes, you're right. Okay, there's my Nano. So I'm just going to upload and see if it works. Like I said, Nanos are really slow compared to the Uno. It's so fast to do development on the Uno or pretty much any other Arduino. The Nano is just like, it's so slow. And you're just like sitting there waiting for it to compile. And then when the little yellow light starts to, it like sort of fades on and off, that means it's uploading. Okay, so it's telling us 9%. Oh, uploading. Looks like it worked. Okay, so now I have to close the Arduino because it'll get confused if you run PD and the Arduino at the same time. Start ENSynth again. Oh, wow, look at these numbers. I think I forgot to put a delay in at the end. So now the numbers are coming really quickly. And I think we're going to have to change this a bit. I think we'll have to, I'm going to put a new object in here called ABS. See if this does anything. Okay, so now we're getting only positive numbers. So ABS means absolute. Oops, that's weird. Okay, I'm afraid to turn this on because I don't know what it's gonna sound like. Oh, it's too small. Okay, so we need to change this number. What if we change that to 1,000? Well, my audio device is somewhere else here. Okay, I hope you guys can hear that. Okay, so that's not color information anymore. That's a gyroscope. So if I move this around, it's coming so quickly that I can't really even tell what's happening. It's a little. I don't think this data is not particularly useful. I mean, if you want this kind of a well, I guess it could be useful for some purpose. I was sort of thinking it would change depending on the angle, but I guess it is kind of working. So let's turn that off. I mean, working with raw data like that is kind of difficult. There's ways to sort of smooth it. I was reading today about just a very simple way of adding an array to your Arduino to the variable. So it would like take, say, a sample of 10 numbers, 10 readings, and then it would just pick the average of all of them. So that might be a way to smooth things. There's some smoothing things you can do in PD with some different different libraries, that kind of thing. But I think that working with sensor input going into say music or a synthesizer to create music definitely requires a lot of trial and error and just working with the software. And we're like a couple minutes to 9 o'clock, so I think we're pretty much done. Does anybody have any final questions or any comments? I'm going to make myself big again. Is anybody going to use the Arduino for anything? You guys have plans?
I will, by hook or by crook, try and make this thing generate MIDI for me and use it as a controller, not to play notes necessarily, but to vary parameters.
Oh, yeah. Here, I'll just, there's a couple slides that would be useful here. So I have to make myself small again. Thanks, Neil. Okay, so this is what I did today, just setting up the virtual MIDI device. So that's the IAC driver on the Mac, and then connect pure data to Ableton. This was another thing that I was interested in. This is a Arduino library called Control Surface, And this, I tried to get this to kind of communicate directly from the Arduino to Ableton, which was my main goal. And this is a library that you can use to create your own control surface. So control surface is like, something like this. It's got buttons, it's got like sliders, it's got knobs, all that kind of stuff. So if you want to create your own control surface, you can use a library like this. These are all the Arduinos that it should work with. You can see that the Arduino Nano 33 there is there. The TNTs are also very good. They're probably the #1 choice, in fact, for making your own control surfaces. But yeah, basically it just kind of like it's got a lot of things that you can use to communicate with MIDI in terms of really, really easily implementing MIDI into your Arduino programs. If you do use it, you should get this version of it because supposedly this is the one that's got support for the Nano 33. There are other, like there's, the thing about libraries with the Arduino is there's many, many libraries. And people just keep writing libraries to do the same thing. So there's actually many, many MIDI libraries, and it's really hard to tell which one to use. So I think I would try this one first because apparently it's supposed to work, but like I said, I couldn't, I had a hard time. There's another question. Did you play around with any of the other sensors on the Nano 33? I suppose that temp, humidity, pressure sensors would not be good inputs for PD, but maybe the proximity and digital microphones could give us values that are usable, that are as useful as the color sensor. I haven't played around with temperature, humidity, pressure. I think I will over the summer. I think that it's probably, I don't think it would work necessarily as like a sensor for like performance kind of short-term performance. I think it's more for like long-term sensor reading and saving that information. And I think that I'm kind of interested to use all of them so that I get to play with everything that's on here, because this is a very interesting idea that they've added sensors to this board. I don't know about the proximity. So the proximity is it's sort of an amorphous term. I'm not really sure what it's measuring. It's measuring maybe like the changes of light in a room plus an electrical field or something. I don't know exactly. So that would be interesting to look at. And the digital microphone, yeah, I have no idea. You might be able to make a cool clapper out of it. I don't think this device is going to, record or playback sound or anything like that in any great detail.
Would proximity possibly be an infrared detector?
Yeah, it could be like they use the PIR sensors, which are like the kind of sensors on your garage door lights. It could be something like that. I have some chips that kind of do other stuff with some sort of fields or something. I don't know. All I want, I just want libraries for everything so that I don't care how they work. I just want a library. Does anybody else have any last questions? I think that's all I've got. If anybody does have any ideas for workshops or anything that you would like to learn, we've got a few more that we've got to be programming in the future for Holophon. We've got another one coming up next week, I think. Is it Your Ear is a Microscope, Sound Object Manipulation for All. So that's Adam Basantas from Montreal. So please come out to that workshop, and look forward to the new ones that we're going to be advertising in the fall. I know that Ernie's going to be doing one on MIDI. What's the deal with MIDI? I can't wait for that one. And if you do have any ideas for other stuff, please let us know, because we're always interested in hearing about stuff. But, I think that's it for tonight. Thanks everybody for coming. And we will see you later. Bye-bye.